Hello guys, welcome to my YouTube channel Net Physics by Tanya. In today's second lecture of nuclear physics, we will study nuclear terminology and some numericals based on nuclear size. So, in nuclear terminology, firstly, we will discuss what are isotopes. If two nuclei have same atomic number Z, they are called as isotopes. Isotopes are different form of a single element. For example, I have taken the example of hydrogen atom here, that 1H1, 1H2 and 1H3. You can see here that these are the three different form of a single hydrogen atom with same atomic number Z but different mass number. Note that if Z is same, then chemical properties of all isotope will remain same. Next, we have to discuss what are isobars. If two nuclei have same mass number A but differ in atomic number or number of protons Z, for example 6C14 and 7N14, you can see here in these two examples that they both are having same mass number A but different atomic number. Next we will discuss what are isotones. If two nuclei have same neutron number, that are neutrons, they are called as isotones. For example, carbon 13 and nitrogen 14 nuclei both contains 7 neutrons, so are isotones. For example, I have written here that 6C13 and 7N14. So to find out neutrons, we have to subtract A minus Z, that is equals to N. So here you can subtract 13 minus 6 is equals to 7 in case of carbon, and in case of nitrogen 14 minus 7 is equals to 7. So you can see here that carbon is also giving 7 neutrons and nitrogen is also giving 7 neutrons. So therefore having same neutrons, so they are known as isotones. Next we will discuss what are isomers. If two nuclei have same A and same Z but differ in their nuclear energy state, they also have different lifetimes. For example, if we take the example of carbon here, so that is the ground state energy for the carbon and that is the excited level energy for carbon atom. So here also carbon and here also that is the same carbon. So these two things are having the same A and same Z but differ in their nuclear energy state, that this is the ground level energy and this is the excited level energy. So it will emit a photon here. So these are known as isomers. Next we will discuss what are mirror nuclei. Nuclei with same mass number A but with proton and neutron number interchange and their difference is plus minus 1. For example, I have taken here 4Be7 and 3Li7. So to find out neutron, if we subtract here in case of barium 7 minus 4, that will equal to 3, and in case of lithium 7 minus 3, that is equals to 4, and what we have written here that their difference must be plus minus 1. So if I subtract 4 minus 3, that is equals to plus 1. So that is mirror nuclei. So here's a note, every mirror nuclei is isobar, but this doesn't imply every isobar is not mirror nuclei. So for A, the formula is 2Z plus minus 1, and for this n minus z is equals to plus minus 1, which I have told here that the difference of neutrons and protons must be plus minus 1. So in mode we can say that plus 1. Now further, what are atomic masses? Atomic masses refer to the masses of neutral atom and not of bare nuclei. Thus an atomic mass always includes the masses of Z electrons, and atomic masses are always expressed in units mu, which are so defined that the mass of carbon atom is exactly 12 mu. So the value of 1 mu is equals to 1.66054 into 10 raised to power minus 27 kg, which is approximately equivalent to 931.4 mega electron volt. And in mega, as you all know, that there are 10 raised to power 6 electron volt. So that's all about the atomic masses. Further, there are some rest masses in various units of different particles for like proton, neutron, electron and hydrogen atom. So you can remember all these values in different units, like mass in kg for proton here is 1.6726 into 10 raised to power minus 27. And in mu, the mass of proton will be 1.007276, and in mega electron volt per c square, that is 938.28. So by this table you can remember all the values of various particles in various units. Now, as I have already discussed the basic nuclear properties in the first lecture of this video, that what is nuclear size of a nucleus. So majority of atomic nuclei have spherical shape and only few show departure from spherical symmetry. So I have discussed in detail how to derive this formula in the previous video, that comes out to be R equals to R naught a raised to power 1 by 3, where A is the mass number and R naught is the constant of proportionality, or we can say nuclear radius parameter, and R naught equals to 1.2 fm and 1 fm equals to 10 raised to power minus 15 meter, where this fm represents the Fermi or femtometer. Okay, so we'll discuss further some numericals based on this nuclear size, and we will use this formula to find out the radius of nuclei. So here's the first example, that find the radius of carbon nucleus. So we have to find the radius of carbon nucleus with the help of this formula, because we already know this formula. So as we know that nuclear size is given by this formula, R equals to R naught a raised to power 1 by 3. And as per the question, we have given the value of A for the carbon atom, and we already know that for carbon the value of A is 12. So we have put here the value of A, and already we know R naught 1.2 fm. So putting all the values we were aware of, we got 2.7 fm, means 2.7 Fermi, the radius of carbon nucleus. Further, here's the next example for the topic nuclear size, that if the radius of germanium nucleus is measured to be twice the radius of barium, so how many nucleons are there in germanium nucleus? So here's the solution. As we know the formula that I have already discussed in previous video also and in the previous slide here in this lecture also, that R equals to R naught a raised to power 1 by 3. And according to question, we have given that the radius of germanium is twice the radius of barium. So we have written this thing. So according to the formula, we have put both sides the value of for germanium as well as for the barium atom. So after putting the values, and we know by the question that the value of A for barium is 9 here, and after solving these two equations we got the value of A here 72. So what we got the radius of germanium nucleus. Here it is 72. So that's our answer. So here's the next numerical, that if the radius of aluminium is 3.6 Fermi, so what will be the radius of copper? 64. So as we know this formula, so by this formula we have written here that one side the radius of aluminium with the ratio of radius of carbon, because we have to find the radius of carbon, and the other side we have written according to the formula that R equals to R naught A raised to power 1 by 3. So we were given here that aluminium having the value of A is 27, whereas the copper having the value of A is 64. So in the ratio we have written this, the information regarding. So after calculating both sides, we got that R of copper is equals to 3.6 into 4 by 3. So after solving this, we got 4.8 Fermi. That's the radius of copper. So that's our answer. Now, the next numerical is that find out the ratio of sizes of PB and mg, that is 82 PB 208 and 12 mg 26. So we have to find out the ratio of these two things. So according to the question, we have written here that radius of PB lead and radius of mg within the ratio. So after cancelling the terms, we got this equation according to the formula of R equals to R naught A raised to power 1 by 3. So as we know according to the question that for lead the value of A is 208 and for magnesium the value of A is 26. So after putting both the values within the ratio, we got 8 raised to power 1 by 3, and we all know that the cube root of 8 is 2. So here's we got the ratio of the sizes of lead and magnesium, that is 2 raised to power 1. So that's the answer. Now the next numerical is that the radius of copper nucleus is measured to be 4.8 into 10 raised to power minus 13 centimeter. So we are given here the radius of copper. Find the radius of magnesium. So what we have to do, we have to find the radius of magnesium, and we are given the radius of copper here. Okay. So as we all know that R equals to R naught A raised to power 1 by 3 is the formula of nuclear size. How to find the radius? So what the values in the question were given. So we have put these values here 4.8 in the ratio. Okay. 4.8 into 10 raised to power minus 13 upon में R of mg, and in the right hand side R naught A raised to power 1 by 3. So for copper the value of A is 64 and for magnesium the value of A is 27. So after cancelling and calculating the terms, we got radius for mg, this equation. So after solving this equation, as we know the cube root of 64 is 4 here. So and 27 is 3, 4.8 into 10 raised to power minus 3. So after solving this equation, we got 3.6 into 10 raised to power minus 13, and by this we have written this 3.6 into 10 raised to power minus 15 meter. So that's the answer. Thanks for watching my video. Stay tuned for some more videos. Like, share and subscribe my channel. Thank you.